Hello everyone, welcome to Equal To, and this is episode 19 of our Polynomials playlist. In the previous video, we solved a couple of examples using the identities that we already learned, and in this video, we are going to learn a new identity. Only one identity, only one new identity, but we are going to use that in a couple of examples as well. Okay, so this is that identity. Okay, here it goes. X plus y plus z the whole squared is equal to x squared plus y squared plus z squared plus 2xy plus 2yz plus 2xz. Okay, now before getting into the definition, you can easily remember this like x, y, z. Right, you are going to pair x and y, you are going to pair y and z, and you are going to pair x and z. Okay, so that is how you are going to remember these three terms at the last. Okay, now I hope you can remember this. This is not a difficult identity to have in your mind. It's just x squared plus y squared plus z squared plus 2 xy plus xz plus yz. Okay, or you can also say xy, yz and xz. The order doesn't really matter. Okay, now how can we derive this identity? Okay, now x plus y plus z the whole square. This is the identity, right? Now let us say we are assuming that t is equal to x plus y. Okay, we are assuming that t is equal to x plus y. This identity can then be written as t plus z the whole square, right? T plus z the whole square. Now this is an identity that we already know. X plus y the whole square is an identity that we already know, right? So using that identity, you can express this to t squared plus 2tz plus z square, right? Because this is an identity that we already know and we are just applying that here. X plus y the whole squared is equal to x squared plus 2xy plus y squared. Instead of x and y, we have t and z. Okay, so that is the expansion here. Now you are going to substitute x plus y instead of t. Okay, so that is going to be x plus y the whole squared instead of t squared plus 2 into x plus y into z plus z squared. Okay, now let me first expand this x plus y whole squared at the first. So that is x squared plus 2xy plus y squared, and then we have 2 into x plus y into z. Okay, so that is going to be 2xz plus 2yz plus z square. Okay, so that is the derivation. Now if you just rearrange these terms, let me erase these things, and I'm going to move this to the top. Okay, now if we rearrange these terms, x squared, y squared and z square at the beginning, you have 2xy plus 2yz plus 2xz. Okay, so that is how we derive this identity. So this derivation, they are not going to ask you to derive this identity per se, but just it might be useful for you. If you just forgot it, you can easily derive this, right? Just you are going to assume that x plus y is equal to t, and you can expand it and then further substitute x plus y instead of t. So that is how you can derive this identity, and it's quite easy to remember as well. Okay, it's a very useful identity. We are going to solve problems using this. Moving to example 14. Okay, this is something that is going to use the formula that we just learned, the algebraic identity that we learned. Okay, so we have 3a plus 4b plus 5c the whole square. 3a plus 4b plus 5c the whole square. Okay, now instead of x we have 3a, y we have 4a, instead of z we have 5c. So that is it. Now you are just going to use the same identity. Let me just write that once again here. So x plus y plus z the whole squared is equal to x squared plus y squared plus z squared plus 2xy plus 2yz plus 2xz. Okay, quite a lengthy identity, but it's quite easy for you to remember as well. Okay, now we are just going to apply these or substitute these values in the place of x, y and z. Okay, so 3a the whole squared plus 4b the whole squared plus 5c the whole squared plus 2 into what is x? 3a. What is y? 4b. Plus 2 into what is y? 4b. What is z? 5c. Plus 2 into what is x? 3a. What is z? 5c. Okay, now we are just going to simplify it further, or rather expand it further, evaluate it further. So 3a squared is 3a the whole squared is 9a squared plus 4b the whole squared is 16b squared plus 5c the whole squared is equal to 25c squared plus 2 into, here we have 2 into 3 into 4. 2 into 3 is 6, 6 times 4 is 24. So that is going to be 24ab plus the next term here have is 2 into 4 into 5. 2 into 4 is 8, 8 times 5 is 40. So 40bc plus the last term that we have is 2 into 3 into 5. 2 into 3 is 6, 6 times 5 is 30. So 30ac. So that is your answer. I am just going to write it once again here. 9a squared plus 16b squared plus 25c squared plus 24ab plus 40bc plus 30ac. That is the answer to this question. Okay, we have written it in the expanded form and we have just used that identity. This is very simple to solve. Okay, very simple to solve. You have just used that identity to expand this expression 3a plus 4b plus 5c the whole square. Okay, now moving on to the next example. This is very similar to the example that we just solved, except for the signs that we have in between. The identity that we learned is x plus y plus z the whole square. It's always recommended for you to write the identity at the beginning of the question so that it gets you marks as well. Apart from that, it's easier for you to remember it while evaluating, right? X plus y plus z the whole square plus 2xy plus 2yz plus 2xz. Okay, now we are just going to do a very simple thing that is going to allow you to use this formula to solve this one. Okay, what you are going to do is you are going to have 4a as x and minus 2b as y and minus 3c as z and whole squared. Okay, so now it is of the form x plus y plus z the whole squared, right? So all you have just done is you have expressed it in terms of plus signs and you have assumed minus 2b to be y and minus 3c to be z. Okay, now we are just going to apply in that expression. So x squared is going to be 4a the whole squared plus y squared is going to be minus 2b the whole squared plus z squared is going to be minus 3c the whole squared plus 2 into x is 4a and y is minus 2b plus 2 into y is minus 2b and z is minus 3c plus 2 into x is 4a and z is minus 3c. Okay, so that are all the terms. Now further we are going to evaluate it or expand it. So 4a squared, 4a the whole squared is 16a squared plus minus 2b the whole squared. When a negative number is being squared, it comes out to be a positive number, right? So it becomes 4b squared and again minus 3 the whole squared. Again it's a negative number, but on squaring it becomes positive. So it's going to be 9c squared, and in this term we have 2, 4 and minus 2. Okay, 2 into 4 is 8, 8 into minus 2 is minus 16. So it's minus 16ab. And then in the next term we have two negative signs. Okay, so that becomes positive. So it's 2 into 2 into 3. 2 into 2 is 4, 4 times 3 is 12. So it's going to be plus 12bc. And the last term is 2 into 4a into minus 3c. Since we have only one negative sign here, it's going to be a negative term. Okay, it's going to be a negative term and it's 2 into 4 is 8, 8 times 3 is 24, so it's minus 24 AC, and that is the answer to this question. Okay, you have expanded it using that formula x plus y plus z the whole square. You have just assumed that y is equal to minus 2b and z is equal to minus 3c, and you have applied that formula. Very easy, nice and simple, easy to solve. Okay, all you have to do is just remember this formula. Okay, now moving on to the next subdivision. This is going to be the last subdivision for this video, or last question for this video. So here we are going to factorize this polynomial using the identity that we just learned. Okay, so it's 4x squared plus y squared plus z squared minus 4xy minus 2yz plus 4xz. Okay, now you might not actually get how you can factorize them easily, but let us try something. Okay, so this xy term, it's negative, right? Xy term is negative, so that means either x or y should be negative. Both are definitely not negative, only one is negative. Okay, and only one is negative. And then we have this yz term. Okay, okay, so there should be a comma here. Okay, now then we have yz term, and that is also a negative term, so only one should be negative. Okay, now in these two terms y is the common factor, and in these two terms only one should be negative, so you can say that y is a negative number. Y is negative. Okay, you can come to that conclusion. The last term is xz, and that is a positive term, so that means either 2 can be negative or none can be negative. Okay, in the first two cases we know that x is a positive number, and in the second case we know z is a positive number. So x, z, both these numbers are positive numbers, and only y is the negative number here. Okay, so that is the conclusion that we have here. So I am just going to write it at the corner, y is a negative number. Okay, just have this in mind. Now we can proceed to solve this. So 4x squared can be written as 2x the whole square, right? Simple. 4x squared can be written as 2x the whole square. We know y is a negative term, so it should be minus y the whole square, because only then minus y the whole squared it becomes y squared on squaring, right? Because negative numbers on squaring it becomes positive, and then z, as we know, is a positive number, it's just z the whole square. Okay, now we can further write the next terms as well. Plus 2 into x, as we know, is 2x, and y is minus y. Okay, y we know is minus y in this term, right? You can consider this to be x squared plus y squared plus z squared, because that is how we have come up with. So in place of you can say this is capital X, this is capital Y, this is capital Z, and a formula is, let us just write it in terms of capital letters, x plus y plus z the whole square. Okay, now we have done it in that case. You can just assume it to be like that, because there are too many x and y's and z's, right? Okay, so this term is 2 into 2x into minus y. The next term is minus 2yz, right? So that again is plus 2 into y is minus y in this case, and z is just z. Okay, and the last term is 2 into 2x into z. Okay, now all I have done is we know the identity, right? The identity is x squared plus y squared plus z squared plus 2 into xy plus 2 into yz plus 2 into xz. We know the identity. I've just tried to write this polynomial in terms of, or in the form of, this identity. Okay, now as you can see, this polynomial is in the form of identity, right? X squared plus y squared plus z squared. Here minus 2 is 2x is our x, so x squared plus y squared plus z squared, and this is our 2xy term, and this is our 2yz term, and this is our 2xz term. Okay, now since we have established in that form, you can just factorize or you can just simplify it and write it as 2x minus y plus z the whole squared, right? Because this expression can be written in the form like this, right? Okay, that is the compressed form and this is the expanded form. So this is the expanded form, we have compressed it and written it as 2x minus y plus z the whole square. So this is the simplified form, but to factorize, or the factorized form would be 2x minus y plus z into 2x minus y plus z into 2x minus y plus z. Okay, so that is how we write our factorized form, right? So you can just write it in that form. This is very simple. I don't know if you have got it completely. If you don't have a clear understanding, please let me know. I'll get back to you somehow. I'll try to make it understand, but the basic concept is that you're trying to express this in terms of this algebraic identity and you're trying to simplify it further. Okay, so that is all that we have done here. These steps that we have done at the top are just effort to make this similar to the algebraic identity. Okay, so that is all, and that is all for this video. I hope you understood this. If you have any questions, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. See you in the next video. Bye for now.